Hello, welcome to the second lecture of week 3, Rise of Modern Science. This lecture is a continuation of history of Western science. The last lecture described the state of science in ancient times and the Middle Ages of Europe. In that lecture, we learned how Western science was trying to find its feet and to free itself from the clutches of philosophy and religion. This lecture will introduce you to how that science finally became independent. Furthermore, the 20th century scientific revolution will also be discussed. It is in this century that science reached zenith. Here, you will read about the ingenuity of man, modern Homo sapiens, in using scientific knowledge to produce products that are both useful and harmful to him. The objective below specifies what you are expected to have learnt after studying this lecture. At the end of this lecture, you should be able to 1. Compare accurately the geocentric and heliocentric theories of heavenly motions. Write concisely on the contribution of Galileo, Kepler, and Newton towards the change in scientific outlook of the 16th and 17th centuries. Explain briefly why the 19th century is regarded as the beginning of the scientific age. Rise of modern science. This topic will be discussed under the following 2 subheadings. 1. The scientific revolution and the classic ages of science. The scientific revolution. This was a period that witnessed a complex change in scientific outlook. It started in the late 15th century and reached its highest point in the 16th and 17th century. Through experimental science, free from philosophy and religion, emerged in the 16th and 17th century. The first great change in scientific outlook after the Renaissance was made by a Polish mathematician and an astronomer called Nicolaus Copernicus, who lived through the 1473 to 1543. You can recall that we came across a man called Ptolemy of Alexandria in the early part of this course. He was a geographer and an astronomer. He wrote a book called Our Majest. In that book, he showed how the heavenly bodies such as the moon, stars, and sun, and all planets moved. According to him, the earth is located at the center of the universe, and all other heavenly bodies moved around it in circles. This view can be called the Ptolemaic system or geocentric system of the geocentric theory. You can see that in the image shown on the screen. By now you may be asking, how does Copernicus come into all this? Ptolemaic system was the view which people of that time had of movement of heavenly bodies, until Copernicus came along and challenged it. To Copernicus, the sun is at the center of the universe, while the earth and other heavenly bodies moved around it in a uniform circular motion. This view is known as Copernican world system or heliocentric theory. The Copernican universe. It is important to note that Copernican theory was not based on experimentation. He based his theory on logical assumption of hypotheses and his taste for aesthetic symmetry. He considered theory as a serious work in astronomy rather than in philosophy, so he set out to justify it observationally and mathematically. As a result, he had a lot of conflict with the church authorities. The implication of his theory is that humanity no longer stands at the center of creation, since the earth is no longer at the center of the universe. It is not surprising to know that people of that time and their authority felt bad over the affront to them and their earth not being the center of attraction in the universe. Galileo, 1564 to 1642, an Italian, provided the most beautiful evidence to justify that ancient authority should no longer be accepted without criticism. He invented a telescope and used it to view the heavens, and thus confirmed that Copernican theory that the sun was at the center of the universe. Galileo also got into trouble with the church authority for his audacity to be on the side of Copernicus. Credit is usually given to Galileo for discovering and establishing the true method of physical sciences. This is because he combined experimental and inductive method with mathematical deduction to obtain his results. You will learn the meaning of induction and deduction in subsequent units. The experiment he carried out was to use the telescope to view the heavens. You will recall that it was said in lecture 2 of week 1 that whosoever experiments after observation and hypothesis formulation are carried out becomes truly scientific in his approach. Experimentation is the very essence of the scientific method. We can safely say that one of the greatest scientific discoveries of Galileo was the invention of the scientific instrument of observation called the telescope. With the aid of this telescope, he saw countless stars whose existence no one had suspected. At the same time, Galileo was searching the heavens with his telescope in Germany. Johannes Kepler, 1571 to 1630, was searching them with his mind. He was the first to apply mathematics as an empirical instrument in searching for the laws of heavenly motions. He was an advocate of the heliocentric theory. Greatest achievement as an astronomer was the discovery of the 3 laws of planetary motions. The laws are as follows. All planet travels about the sun in an elliptical oval path. A planet moves faster in its orbit as it nears the sun. 3. There is a relationship between its distance from the sun and the time it takes to make an orbit. That is one movement around the sun. What Galileo and Kepler could not provide, although they tried quite hard, were answers to these questions. If the earth revolves on its axis around the sun, then why does object not fly off it? If you ask me. How is it possible for earth suspended in empty space to go round the sun, whether it circles or eclipses, without anyone pushing it or anything? These answers were long in the coming. The year 1660 seems to be the most important time in early development of modern science. It was in that year that Isaac Newton, 1642 to 1727 AD, achieved one of the greatest successes of all times. In other words, through his work, he confirmed the results of Copernicus, Kepler, and Galileo. All the results of Copernicus, Kepler, and Galileo and Newton form the first. This means that science aimed to be able to combine any unrelated facts so as to be able to explain, predict, and control nature. Newton proposed a principle of gravitational attraction and used it to answer the question posed by the works of Galileo and Kepler. The basic ideas in the principle are each object in the universe attracts all other bodies to the center of its form, and that if the mass of one of the 2 attracting bodies is double, the gravitational attraction will also be double. But if their distance apart is double, the force will be only 1/4 as great. By using this theory, Newton was able to explain the motion of the planet around the sun, the familiar fall to the ground of fruits from trees, and all other motions which were on the earth. The accuracy of Newton's theory or law proved to be amazing. With the help of his theory, generations of astronomers have been able to explain and predict astronomically. Do the words theory and predict ring a bell in your mind? As we mentioned in the lecture 2 of this unit, every good theory has a predictive value. Thus, Newton's theory is a good one. Francis Bacon, 1561 to 1626 AD, is regarded as the first person to attempt to arrange the steps of scientific method in a logical manner. He emphasized the role of scientific discovery and invention in giving man mastery over the forces of nature. At last, we have seen the true becoming of modern science. A Renaissance science was still a branch of philosophy, but after that period, it succeeded in finding out its own method of observation and experiment. Where it is necessary, mathematical analysis is also used. The classic ages of science, 18th and 19th century. At the time of scientific revolution, scientific advances were restricted largely to physics, astronomy, and chemistry. That is to say, physical sciences. In the 18th and 19th century, further advances were made in mathematics and astronomy. One of the major advances in chemistry in the 18th century was the discovery of the role of air and gases, generally in chemical reactions. Such chemical reactions include combustion, which is burning, and respiration in organisms. Laurent Lavoisier, 1743 to 1794. He discovered that it was a gas, which he named oxygen, that enables combustion, burning, and respiration to take place. As you might be aware, people of nowadays now take it for granted that we need air in order to breathe well. Try to imagine what people that lived before Lavoisier thought of an activity like burning of things. They were not able to explain why burning takes place in certain situations and not others. So you can appreciate the beauty of discovery and invention. The revolution in chemistry was both a revolution in method as well as ideas. Lavoisier insisted that the central concern of the new chemistry was the use of gravimetric method. This involves paying particular attention to the weight of the ingredient involved in chemical reactions and of the products that result. He found from the experiment that the weight of the product of combustion, that's burning, for instance, equals that of the original ingredient. This discovery became known as the law of the conversion of mass, or matter, as the case may be. The 19th century was being regarded as the beginning of the scientific age because of many reasons. They include the following. There was a very rapid growth of knowledge of nature during this period. It was during this period that the view or idea people had of the universe was changed by recognizing that man was also subject to the same physical laws and processes as the world around him. Therefore, man should also be studied. It was also realized that all the field of knowledge could use the scientific method and not just pure science alone. Again, within this century, people started carrying out scientific investigation with the sole objective of gaining more knowledge. It was understood that such investigators were moved by the insatiable curiosity concerning the unknown. The knowledge obtained by investigators above was used to apply researchers to provide and invent things. For example, in 1864, James Clerk Maxwell, a British physicist, conducted research to determine the relationship between heat and other forms of energy. He expressed his findings in mathematical formulas to design cars and even rocket engines that use fuel more efficiently. Thus, within this period, scientific research and industrial development went hand in hand. This was unlike in former ages when the need to solve a problem led to invention unless those inventions were produced by accident. You may observe that the study of living things, biology, had lagged far behind chemistry and physics. This was because people at that time believed that organisms were too complex for them to study. However, in the 19th century, researchers' interests shifted from astronomy to geology and from physics to biology. The major discovery of the 19th century was the following: the understanding that atoms and molecules are the basic building blocks of matter. Does this statement remind you of anything? If it does, it means you have understood the material presented before you in the previous unit. In previous lectures, we've learned that the early Greek tries to find out what matter was made of. Various answers were given, such as water, divine fire, and atoms. It was Democritus that mentioned atoms. It was only in the 19th century that John Dalton confirmed that Democritus was right. Let us use water to illustrate. It is known that water can be produced by combining hydrogen atoms and oxygen atoms. Once you combine two atoms of hydrogen with one atom of oxygen, water is produced. The understanding that cells are the basic building block of living things, although in 1965, Robert Hooke used his primitive microscope to observe that plant material have a cellular structure. He only saw the outline of the cell and not what was inside. To say that the cell are the basic building block of living things means that every human being, other animals, and plants are built up from cells. It is just like building a house with blocks. Living things are built up with cells. In human beings also, the cells which aid reproduction are called gametes. The gametes from father are called sperms, while those from the mothers are called eggs or ova. The combination of sperm of a man and the egg from his wife brings pregnancy, which ultimately results in bringing babies or babies into the world after 9 months of pregnancy. This is what happens in all living things, whether plants or animals. That is why it is said that cells are the building blocks of living things. The statement that cells are the building block of living things is called the cell theory. In the previous lecture, it was defined as a phenomenon. Scientists observed from experience that all living things are composed of cells. They also observed that each living thing was built up by combining cells. So in 1839, two scientists, Theodore Schwann and Matthias Sheldon, made this general statement or proposed a theory that cells of universal occurrence and are the basic building blocks of an organism, and that cells came from pre-existing cells. This theory is one of the fundamental theories of biology. Another fundamental theory of biology proposed in the 19th century was the theory of evolution. Although there are many theories of evolution, the one which scientists could accept is the theory of evolution by natural selection, which was proposed by Charles Darwin in 1859. Charles Darwin is also called Newton of biology. This is because the publication of his theory led to an explosive growth of biological sciences, just as Newton's work stimulated the physical sciences. People started carrying out experiments here and there, either to confirm Darwin's theory or to prove him wrong. Some people were not prepared to accept the ultimate dignity of having descended from a bacterium and of sharing common ancestors with monkeys, apes, and even worms. The theory ignites an excitement in the scientific community that has not yet fully died. People were then willing to research on plants, animals, which they thought were too complex to study. In this lecture, you have learned how there was a complete revolution in scientific outlook from the late 15th century onwards. Experimental science became independent of philosophy and religion. You have also learned that the 18th and 19th century are called the classic ages of science because of the explosion in knowledge of nature that occurred at that time. You will also note that the explosion is still continuing. If you think about all the stories about genetic engineering, chemical engineering, cloning of animals, and so on. The main point in this unit includes the following. There was a complete change in scientific outlook from the late 15th century up to the 17th century. True experimental science, free from philosophy and religion, emerged in the 16th and 17th century. The first great change in scientific outlook was made by Nicolaus Copernicus, 1473 to 1543. He disproved the Ptolemaic system or geocentric theory, which stated that the Earth was the center of the universe and all other heavenly bodies moved around it in circles. To Copernicus, the sun was the center of the universe, while the Earth and other heavenly bodies moved around it in the uniform circular motion. This view is called the Copernican world system or heliocentric theory. Copernicus got into trouble with the church authority who believed the geocentric theory, but it did not make him give up his theory. The next person that brought this change in scientific outlook was Galileo. That was in the 1564 to 1642. While Copernicus obtained his result from using simple observation and mathematics, Galileo added experiment to those two. He invented a scientific instrument of observation called the telescope. The instrument enabled him to extend his senses of sight, and he saw clearly that the sun was at the center of the universe. So I was confirming the theory of Copernicus. Galileo is thus called the discoverer of the true research method of physical sciences. Johannes Kepler, 1573 to 1630, discovered the laws that govern movement of the heavenly bodies. He was the first person to apply mathematics as an empirical instrument to discover these laws. However, in spite of this result, Galileo and Kepler could not answer why objects do not fly off the earth. Considering this submission that the earth evolves or moves around the sun, another question they couldn't answer was how it was possible for the earth, which was suspended in space, to go around the sun without anything pushing it. It was in the same year, 1660, that these questions were answered by Isaac Newton, 1642 to 1727 AD. He proposed a theory of gravitational attraction to answer these questions. Gravitation is the force that pulls every object in the universe towards every other object in the universe. Therefore, the object pulls object within it towards its center, so that the reason they don't fly or fall off the earth when it moves around the sun. The sun also has a center of gravitation, which pulls the earth and all other heavenly bodies around it. Francis Bacon, 1561 to 1626, was the first person who attempted to arrange the steps of the scientific method in a logical manner. The classic ages of science were the 18th and 19th century, an explosion in growth of knowledge of nature occurred at this point, especially in the 19th century. The explosion in chemistry was started by Antoine Laurent Lavoisier in 1743 to 1794. He discovered that it was a gas, which he called oxygen, that enables combustion and respiration to take place. He also introduced the gravimetric method of carrying out research in chemistry. In the 19th century, there was a common understanding that atoms and molecules were the basic building blocks of matter, and that cells are the basic building blocks of living things. This statement led to the formulation of the cell theory by Schwann and Matthias Schleiden in 1839. The cell theory is one of the important fundamental theory of biology. Another fundamental theory of biology is the theory of evolution by natural selection. It was proposed by Charles Darwin in 1859. Thank you very much. See you in the next lecture.